Hello all, welcome back to YouTube channel. Today we're gonna see about osteoarthritis detection and classification. First of all, I will explain your abstract, like what we have done. Osteoarthritis is a progressive joint disorder that cause pain and limited mobility affecting millions of people worldwide. Early detection is essential for timely medical intervention, which can help improve patient outcomes. This project aims to automate the detection of osteoarthritis using deep learning based image classification techniques. Specifically, three pre-trained convolutional neural network CNN models like VGG19, ResNet 50, and MobileNet V2 are utilized to extract features and classify medical images of knee X-rays. These models are fine-tuned and evaluated to determine their effectiveness and diagnosis OA. To assess their performance, metrics such as accuracy, precision, recall, and F1 score are used for comparison. The kinds of the finds of these studies could contribute to development of AI-powered diagnostic tools, enhancing the efficiency and accuracy of osteoarthritis detection in healthcare settings. Sure, I'll explain our introduction in short. Our osteoarthritis is a chronic degenerative joint pain disease that affects millions globally and leading to pain, stiffness, and restricted mobility. It primarily destroys the articular cartilage, which conclusions bone within joints. As it wears down, bones begins to rub against each other, causing inflammation and knee osteoarthritis is commonly due to knee weight bearing function and mechanical stress. Various factors contribute to OA, including aging, obesity, genetics, prior injuries, or prospective strain on joints. While aging remains a primary risk factor, younger individuals, specifically athletes or other those physical demanding jobs, can also develop OA. Other contributors include metabolic disorder, inflammatory condition like rheumatoid arthritis, hormonal imbalances, and inactive lifestyle. The symptoms of knee OA vary in severity but generally include joint pain, stiffness, swelling, limited range of motion, grinding sensation within joint. Diagnosis primarily relies on clinical evaluation and radiography imaging, with the X-rays image helping to identify key OA indicators like joint space narrowing, steroids, and bone cylinders. The severity of OA is commonly classified using KA, that is Kilgreen-Lawrence grading systems, with a range of grading 0 as healthy joint to grade A to grade 4, which is severity. That is, you can see here. Grade 0 is healthy, and grade 1 is doubtful, and grade 2 is minimum, and the grade 3 is moderate, and grade 4 is severe. Like this, we have separated. And then in our traditional OA diagnosis, depends on radiologist manual analyzing X-rays, which is timely consumer object and subjective, often indicating to inconsistent results. Each OA can be particularly consuming and subjective, and then it's challenging to detect. Delayed diagnosis may result in irreversible cartilage demand. Additionally, access to skilled radiologists is limited in many regions, further delaying time intervention. With growing availability of medical image data, artificial intelligence has emerged as promising solution to address these challenges. Okay. And then the study focuses on leveraging pre-trained CNN architecture such as BG16, ResNet 50, MobileNet. BG16 is known for its deep feature extraction capabilities. ResNet incorporates residual connection to enhance training efficiency. MobileNet V2 is a lightweight yet powerful model suitable for medical image classification. Yeah. Now I will show you a problem statement. Here are place a problem statement. Arthritis is a progressive joint pain disorder that leads to pain, stiffness, and reduced mobility, significantly impacting patients' quality of life. Traditionally, diagnostic methods rely on manual assessment of X-ray images, which can be time-consuming and prone to human error. There is a need for automated AI-driven approach to accurately detect and classify the osteoarthritis severity. This project aims to develop a deep learning-based system utilizing VGS 19, ResNet 50, and mobile net V2 for effective and accurate OEM detection. That's the objective. I will show you a block diagram first. First, what you will do is you took a data set collection from Kaggle and we are doing pre-processing such as prescaling, normalizing, or intercept splitting. Our splitting is done into 80% for training and 20% for testing. A mobile training is done in PCC 19 and testnet 50 and mobile net. From this, which model has more accuracy for each image, we will take that image. First of all, we will take an image and view into three models. In that, which has high confidence score, so that image will be printed. Okay, I will show you how it works. So just before I run this, before that I will show you our data set. You can see our data set. Yeah, this is our data set. So this type of measures will be as healthy one. And this is 24 5 grades. And this is severity. You can see the changes. You can see this right. Severity. And our results are there. Our mobile results you can see here. We got up to uh, 87 accuracy in mobile web. There's no 50 we got up to 92. And this BJT, this we got up to 84 accuracy. So the image should go to three models. From that model, you can see with just high confidence score, so you will put that. Run this now, you can see this ones. Yeah, you can see formula loader. Yeah, this is the first screen. So we will next to go to a second screen. Second window. From this we can building, you can touch every one of the image from here. The one is this. I can see that the model is predicted as 90 and the prediction is healthy and our confidence score is 90. Okay, we'll do for other three. Yeah, mobile and has done this. Predicted as normal thing. See moderate one and our confidence score is 83%. So this is how this project works. Now, if you have any doubt regarding this project, you can leave a comment in comment section and don't forget to like, share, and subscribe. Thank you.